So what we study is we study the mechanical behavior of materials. So this means we want to understand how materials deform, dissipate energy, and then eventually fracture with all sorts of applied loads. So one of the tools that we use is we use digital image correlation. And so that's a tool that's a non-contact strain measurement tool. To use this tool, we apply a random speckle pattern to our sample surface. So we paint it white with a black speckle pattern, and that gives us some pattern that we can visually recognize on the sample surface. And the second thing that that pattern does is it deforms with the sample. So if we apply a load, the surface pattern is going to deform along with the sample. And so we apply lots of different loads to our sample, and we can measure then the 2D and 3D deformations of that sample surface with our applied load. We are taking pictures of the sample surface as we deform it, and then afterwards we go in with the software and it can correlate what this speckle pattern did between each of these images, and from that we get our 2D or 3D deformation fields, which in turn gives us our strains. So we have an understanding then of the stress-strain behavior, and what we can do is we can make computational models that describe how the material will then deform with these applied loads. So we want to understand how materials can be used in structural applications, or how they respond when you have loads applied. So this means this could be applicable to sheet metal forming in the automobile industry, or this could be applicable to a structural component in an airplane and how that's going to respond to the applied loads. And so we want to look into new materials and understand their structural properties, which means then how they respond to these applied loads and how they'll perform in their applications.